How's it going, everybody, and welcome back to our Enterprise Practice Lab. In this video, we're going to be focusing on getting the MPLS service provider online and getting all of that squared away. I don't think it's going to take us very long to get it working. I'm not going to go into an in-depth breakdown of how MPLS VPNs work, but what I will do is kind of give a why we're doing certain things a certain way. So essentially what we're going to do is set up IGP, set up LDP, and let me go ahead and pull up the this guy right here, and we're gonna set up OSPF between all the devices, ensure loopback 0 is advertised into OSPF, and then enable LDP on all devices. We're going to configure CSR46 and XR55 as IBGP route reflectors. We're going to form IBGP peerings from the route reflectors to the PE devices, and form EBGP peerings from the PE devices to the customer devices. So that's essentially what we're going to go do. So that means that's 42, 47. Well, 42 is going to connect to 31, and 45 is going to connect to 35 and 36. That'll initially be all the connectivity we'll have. And then once we have this done and we have route reachability where we want it, then we'll be able to go forward with the remainder of our configuration and get that all squared away. Once that's in play, we'll be in pretty good shape. We'll start being able to take routes from all over here and then advertise them into BGP. Whether we do redistribution or we do network statements, whatever the case might be. And I'll talk a little bit about how BGP does the job it needs to do on the CSRs. Because if I pull up the CSRs and look at CSR 31, for example, I do a show IP route, I'm going to see a bunch of routes in my routing table, which is good. That's what I want to see. And I should have reachability to most things, and I haven't tested reachability on the internet side yet, but that's okay. I'll come back to that when we get to DMVPN, and we'll make sure that the underlay connectivity is in play. But for the most part, we have everything where we want it to be. So that's essentially what we're going to go do. So I'm going to go ahead and get out of the way, pull up our lab guide here. I'm going to scoot this guy up here. So what we're going to do is we're going to start on CSR 42, and we're going to do step 1 first. So let's go ahead and knock that out. So we're going to start on CSR 42 and work our way across. Global config. I'm going to type in, there's a couple ways that you can do this. So there's the quick way, which is doing OSPF globally and enabling MPLS on all interfaces. So I'll show you guys how to do it actually both ways. So in this box here, since I'll do it at the interface level, I'll type in interface gig 1, IP OSPF 1, area 0, IP, and then we're typing MPLS. We'll type in LDP, IGP autoconfig. And then we'll type in interface loopback 0, and I'll type that in. So do show run interface gig 1 by doing the, actually, no, sorry, I tell you take it off. My mistake. So router OSPF, actually no, MPLS, so interface gig 1, MPLS IP. That's right. That's how you do that. So now do show run interface gig 1. Now it's there. So MPLS IP, and it'll turn MPLS on at the interface level and all that stuff. So now for the rest of them, I'm going to go do it globally because that's just, in my opinion, easier from a scale perspective. So CSR 43, I'm going to go to router OSPF 1. I'm going to type in network of 10.0.0.0, 0.255.255.255, excuse me, and then MPLS LDP autoconfig. So we're going to form an OSPF adjacency there, and then momentarily we should form a MPLS connection just like that. So that it's going to be repetitive the rest of the devices. So I'm going to type in do show run pipe section OSPF, and I'm going to do the CCIE pro tip config. So on 44, do the exact same thing. Copy pasta, and then we're going to go to 45. Copy pasta, and then we're going to go to 46. Just work our way across. Just like that. Okay, now that we have that set up, we should be forming an OSPF peering with just about everybody here momentarily, and 44 should come online here momentarily. So let me just go back in time and make sure everything is configured. So we got a connection to 43. 43 has a connection to 46 and 44. 44 just took forever. So 44, 43, there's 45, and 46 should be coming up momentarily. Do show IP interface brief, and there's 46. I'm just impatient. And then 45 should have appearing to 44, and so should 46. There it goes. So the next one will be to configure XRV47, 48, then XR55. So 47, log in with Rob and Cisco, go to global config. We're going to type in router OSPF 1. Router ID here is going to be 10.0.0.47. Type in area 0, interface gig 00000, and gig 1, interface loopback 0. And then I'm going to exit out, and I'll type in MPLS LDP autoconfig, and we're going to do it at the area level. So we're going to do that now. Just because I've turned it on at the area level in OSPF, MPLS is not turned on globally. So I'm going to actually router OSPF 1. I'm going to type in log adjacency changes, root, and then MPLS LDP, and I'm going to type in log neighbor, and then router ID is going to be 10.0.0.47. So I'm going to go ahead and do a show config. So you have to configure OSPF, and you have to configure MPLS LDP to form the neighbors. So I'm going to go ahead and take all of this config here, and I'll make a slight adjustment to it. Go ahead and commit that config. Let me go ahead and pull up our notepad doc here. Let me go ahead and pull this in, and I'm just going to do 48 real quick. And copy and paste that into 48. 48 is over here. Go to global config and paste that in right there. Commit it. And momentarily I should have peerings up to 44. Technically I don't need gig 01. That doesn't make much of a difference, but that's okay either way. So do show IP route. I have a bunch of OSPF routes in my routing table, and so do show MPLS forwarding table. And I have a bunch of LDP labels in my label database. Now the last one here is going to be setting up OSPF for XR55. So basically doing the exact same thing. So I'm just going to say here, this is going to be 55. And technically speaking, I don't need LDP enabled between or label switching built in for 46 and for 55, but it doesn't hurt. XR55. And copy and paste. Commit that. And so we should have connectivity up here in just a minute. Okay, so now that we've got that, that'll make that really, really easy. So we're going to have 43 and 44 do show IP route, and do show MPLS forwarding. Excellent. So we have, looks like we have a bunch of connectivity up and running between all of these devices. So on CSR 46, I'm going to go ahead and configure him for a route reflector. So I'm going to type in router BGP 4, no BGP default IPv4, and I'm going to type in neighbor. And actually, I need to turn on, I don't need to turn on any address families yet. But if I do show run section BGP, the address family will enable once I activate the peering. But I don't need IPv4. I only need VPNV4, because that's the only address family I'm going to be forwarding traffic for. And we'll talk about that here in just a minute. So I'm going to type in neighbor of 10.0.0.42 remote AS of 4, update source loopback 0, and then I'm going to say address family VPNV4 unicast. I'm going to activate the peering and say route reflector client. Simple as that. Now I'm going to jump out of global config real quick, hit the up arrow a few times, and change this to be 45. And do a update dash source loopback, update source loopback 0. And I'm going to do 47. Just so we have everything squared away. 47. And then we're going to do 48. No point of having 2 route reflectors if I've only got the iOS box that's a route reflector pairing to the iOS PE devices. So address family VPNV4, and then we're going to go to 45. It's going to be an activate and a route reflector client. It's going to be a 47 and a route reflector client, and then a 48 and a route reflector client. So do show run section BGP. So here's my config. IPv4 unicast, the address family is there, but we're not using it. But we can see all the connectivity that we have in play is squared away. So that'll pretty much be the configuration we're going to need. So then what I'm going to go do is on XR55, I'm going to go ahead and configure him as well, since we're right here. Configuration is a little bit different, but the route reflectors are going to be the most involved config in this design. And then all we have to do is configure the PE devices, CSR42 and XR47, 45, and 48 to peer to 48 into 50 or 46 into 55, and it's a couple of lines of config per box, and we're up and running. So on 55, I'm going to go ahead and exit out of here. Type in router BGP4. Once I have an address family, IPv4 unicast. This has to be working before you can move forward. And then address family VPNV4 unicast. That has to be working as well. So I'm going to type in neighbor of 10.0.0.42, remote AS of 4, update dash source is loopback 0, address family VPNV4 unicast, and I'm going to type in route reflector client. So I get to go do a show config, and this is why I like XR, honestly, because it gives me this config. So then I can just hit the up arrow a couple of times and do 45, copy and paste. I can do 47, copy and paste, and then 48, copy and paste, just like that. If I do a show config, everybody's configured now, and all I have to do is do a commit. Makes it really, really simple. So the next thing I'm going to go ahead and do is go to CSR42 and go router BGP4. Sorry. No, router BGP4. Router BGP4. No BGP. Default IPv4. I'm going to type in neighbor of 10.0.0.46, remote AS of 4, update dash sources loopback 0, address family VPNV4 unicast, and then I just have to activate the peering. Let me jump out of global config real quick and repeat the process here. We're going to do 55. Let's come back over here. 55. And then do update dash source loopback 0. And then address family VPNV4 unicast. VPNV4. And then we're going to activate that peering. So give that a moment. The peering should come online. There it is. So do show run pipe section BGP. And then I take this over to 45. and then I just right click and paste it in. Just that simple. That's the beauty of doing it like this. It makes the deployment really simple when you've got route reflectors in play. 46 and 55 should come online here in just a minute, and then we're going to be in good shape. There it is. Good deal. So now I get to go over to 47 and 48 and configure them respectively. Router BGP4, neighbor of 10.0.0.46, remote AS of 4, update dash source is loopback 0, address family. No, I need to type in address family IPv4 unicast, address family VPNV4 unicast, then go back to the neighbor, and then address family VPNV4 unicast, and that's all I have to do. Show, and then we're going to go 55, and we're going to reapply that, the loopback, and then address family VPNV4 unicast, and that's all we have to do. So we do a show config. That's the syntax we need to do. Grab all of that, and then commit that, and then go over to 48, exit out, and just copy and paste that in. And that should get all of our infrastructure laid out that we need to have in play. Give that a couple of minutes. Well, it won't even take that long. Just a couple of seconds for it to fully come online. There we go. So now I get to get out of here and do a show BGP VPNV4 unicast summary, and I have active peerings set up. So now that we have that in process and we've got all the infrastructure, if you couldn't tell, I've done this a bunch of times. I've set up MPLS VPNs thousands of times, testing them out and practicing them with them. And I've also worked in the service provider world for a while, so I'm pretty familiar with how the process works. Sometimes they do things a little bit differently. There's a big push right now to move to segment routing. So if you're looking at the service provider track at about the same level, I always equate to CCIE enterprise preparation for MPLS VPNs. The level you learn it for CCIE for the lab exam is like just above a CCNA, maybe a low level CCNP in service provider, and you learn a lot more about MPLS VPNs when you're in the SP track, which I plan on doing some coverage of that in something similar to this, but it won't be full blown. It'll be something similar to it for the SP track, but that'll be coming down the road. So now that we have that, and we've got all this stuff done, this is 100% complete. So 1 through 5, all done. The next stage in the process is to form EBGP peerings to the connectivity and get that all squared away. So let's go ahead and start knocking that out. So I'm going to go ahead and minimize this for the time being. I'm going to go ahead and get out of the way. I'm going to come back over here to 42. And we're going to go ahead and on gig 2, so do show IP interface brief, interface gig 2. I've already got it configured. And the next thing I have to do, and I didn't lay this out in the lab guide, there's no specific information here that specifies what VRF you're supposed to use or the route target values. So some of that information, probably an oversight on my part as the lab writer, but I should have spent a little bit more time in that specific area, but it's okay. We'll create a VRF, we'll create a VRF-A or enterprise, not that big of a deal. And then what we're going to go ahead and do is use the route target of probably, I'm going to do a little bit more advanced, which you're probably going to be seeing in CCIE enterprise, where we're going to define actual route target import values and not use the same route target everywhere. So a lot of the times if you're first learning MPLS VPNs and you're learning about the concept of the route target for importing and exporting routes in and out of the VRF with the global routing table, or into the routing table into the VRF, when you're going back and forth between those two, a lot of times you're going to see whoever is walking you through that, and this is across the board, not just one training company. A lot of times you see one route target. to keep it simple. The route target is similarly, it's loosely analogous to an access list or a prefix list. You're determining what other route targets you're going to allow traffic to come into and out of your VRF. So if you create a route target with the appropriate nomenclature, so for example, on a per PE device basis, then you can export your local PE routes and import the other remote PE routes. And I'll explain to you what that means here in just a second. But that's essentially how I like doing it. It gives me route control. So you can do route target 1:1, and as long as you have the same route target everywhere, you're going to have a full mesh of propagation. But you can control what routes you learn from which other remote PEs and how you learn them by having specific route target values, and then you can associate route maps and prefix lists and do policy-based forwarding on that, not PBR, policy-based forwarding on, and not XR. Policy-based forwarding is basically how iOS XR does policy-based routing, but you can do policy-based forwarding where you're going to only allow certain prefixes into your VRF based off of whatever's in a prefix list. So it can get kind of interesting when you get down to the weeds. That's why I need to do a specific set of training on service provider and how that would come into play. But a lot of the stuff that's already on my channel covers that. So let's go ahead and dive into the config of what that's going to look like. So I'm going to use VRF definition enterprise just because it's simple to do. And then underneath here, I'm going to type in RD. In this case here, the route distinguisher is going to be specific to all the routes. So I'm going to type in here, I'm going to say, I'll use my ASN. I'll say 1:4 because it's going to be the first customer right here. The 1 will be the first customer, and I'm AS4. So RD is 1:4, and then my route target, I can do both 1:4. And if I do that across all of my different PE routers, then I'm going to accept any and all routes in it. I'm going to send out 1:4, and I'm going to accept in 1:4. But if I do route target export, for example, and I can do an ASN and then the number, or an IP address and then the N, the number. So NN means any random number. ASN and then the number is any random value. So for example, ASN would be 4:42. 42 being my CSR 42 would be my loopback or my router ID, right? That's how that would be noted. But IP address would be 10.0.0.42:1, for example, right? Because we're pulling that in. So or 4 for my ASN, depending on how you wanted to do it. So I am personally going to go with this nomenclature right here. So I can say on the right-hand side, there's a service provider. The left-hand side is going to be the PE router that I'm receiving the traffic from. Okay, route target export that, and then route target import is going to be 10.0.0. And if I look around, I got 45, 47, and 48. So I'd have to type in 45:4. Now, with this right here, if we were on CSR 45, this right here would be my export value, and this right here would be my import value for traffic coming from CSR 42. So I'm going to repeat the process over here, 47:4, and we're going to do 48:4. So if I do, and then I have to do address family, IPv4 unicast, enable that, and do show run pipe section VRF. That's the configuration. So I'm exporting stuff from 42, and I'm allowing 45, 47, and 48 to come in from the remote sites, or from the remote PEs. And I've got address family IPv4 unicast deployed. Now, what I get to go do is do show run interface gig2. Interface gig2. I get to type in VRF forwarding enterprise. So I'm going to go ahead and hit the enter key. And what I have to go do is I have to reapply this IP address again. Because I've moved gig2 from the global routing table into the VRF enterprise routing table. So if I do show IP route for connected routes, I'm going to see the loopback in gig 1. But if I come over here and I do VRF enterprise connected, I'm going to see just gig 2. Two different routing tables. One is the VRF specific to enterprise, customer enterprise, and then the other one is going to be the global routing table. So now that I've got that done, the next thing for me to go do would be to go over to router BGP4 and type in VRF address family IPv4 VRF enterprise, and it's not going to let me enterprise. And then I get to type in here neighbor of 192.168.31.31, remote AS of 65,001. Okay, that's the first connection I want to have. Now if I go over to 31, I go to global config, I type in router BGP 65,001, I type in neighbor of 192.168.31.42, remote AS of 4. Okay, and now I have to go to address family IPv4 unicast, and then I have to activate that peering. We'll give that a minute to come online. So it's there, right? Now, the caveat is I'm not actually advertising anything. So if I do show BGP IPv4 unicast, I have a bunch of routes on my routing table, right? Now here's the interesting thing. If I go over here to 42, right, the VPN's up. If I do a show IP route VRF enterprise, I'm going to see all these routes in my routing table, right? These are all publicly learned addresses. Well, what's wrong with that? Well, what's wrong with that is I don't want to learn any of these addresses. I don't care about anything reachable on the public internet, especially not via MPLS VPN. So what do I have to do? I have to be careful when I do that, because now that I've got that, if I show MPLS forwarding table, I'm going to have labels for all these guys. There's going to be labels for all this stuff in here, and they're all VPN learned routes. So that's a problem, right? We don't want to end up having a bunch of traffic in my MPLS VPN service provider. They're going to call me up and be like, hey man, what are you doing? So that's not good. So we're going to have to fix that. And that's an relatively easy fix for the most part. But let me go ahead and get 35 up and running as well. So I'm going to go over here to CSR 45. I'm going to go to grab 42's config for show run pipe section VRF and show run pipe section BGP. So what I'm going to do is I'm going to pull up Notepad. I'm going to go ahead and grab the VRF config. This stuff right there. And then I'm going to grab the BGP config. This part right here. Well, actually, I don't need this part right here. I can go without that. So what I'm going to do is I'm going to come back over here. And actually, let me bring this down so you guys can see it. So on this side here, on 45, what I'm going to do is I need to move these around. So 45 is going to be local. So I need to make this a 5 and this a 2. So that I can bring in that guy. And I'm going to copy this in onto 45, paste that in. And then do show IP interface brief. I've got a connection to 35, so I'm going to type in interface gig 2, do show run interface gig 2. Type in VRF forwarding enterprise. And I'm going to reapply the IP address. And then I'm going to go to router BGP4. Address family IPv4 VRF enterprise. I wish it would autocomplete there, but it doesn't. Neighbor of 192.168.35.35. Remote AS of 65035. Okay. And then I'm going to go over here to 35. Type in router BGP 65035. neighbor of 192.168.35.45, remote AS of 4, address family IPv4, and then activate the peering. Give that a second to do its thing. Now, if I go over here to 45, I do a show IP route VRF enterprise, I'm learning a bunch of routes from him. Right? Now, if I go to CSR 46, he's my route reflector. Show BGP VPN V4 unicast. Summary. Sorry. Show BGP VPNV4 unicast all summary. That's right. I forgot about that. So I'm learning 19 routes from one, 16 routes from the other. So I come in here. I'm going to be learning routes from both peers. I don't want to be learning any of these routes. So how can I fix this? How do I get rid of all these routes from what I'm learning? Because this essentially is not how you want to learn or utilize MPLS VPNs. There are use cases where you might have a remote site where it's only got MPLS VPN and then you bring internet over the VPN, so you're backhauling internet over a VPN connection. That's fine. But so there's normally a couple different ways that you can handle this. Normally what you're going to do is on the interfaces that are pointing to the service provider on your router, you're going to place gig 2 and gig 2 here and gig 4. You're going to place those interfaces into a VRF. And then if you're going to do any type of routing, you're going to have a default route or a VRF aware DMVPN configuration and FlexVPN. You can do it with that too. That's going to point to the VRF enabled interface as your underlay. So you're normally not going to do it the way that I have set up. You're normally going to do it, you're going to put your internet facing interfaces into a VRF, and then you're going to have your MPLS routes inside of your global routing table. It's a separation of routes. So because what I have to do now is on gig 3, or on my neighbor statement, on my neighbor from CSR 31 to CSR 42, and from 35 to 45, I have to go through and basically set up prefix lists that deny specific routes and permit other routes. So I'm going to show you guys how this works. Let me go ahead and do this real quick. So let's go ahead and jump on to CSR 31. Now I can do it on CSR 42 as well. I can do it on the provider side inbound. But to me, this is a known issue. So depending on the way it's set up, so let me just go theoretical here for a minute. If you're going for the CCIE lab, this is something, and you know this is going to be a problem, this is something you should know about ahead of time and be able to fix without needing the provider's help. Or you may need the provider's help. They might have an interesting way of handling that. But you should know how to do this. So let me go over here. I'm going to type in on this box right here. I'm going to type in IP prefix list. And I'm going to type the name PL is going to be, what do I want to call this? MPLS VPN advertised. I'm going to permit, in the first sequence number of 5, I'm going to type in 10.0.0.0/8 greater than or equal to 24. So I've got everything in my network is /24s for the most part. I'm going to do that. I'm also going to create another one that is going to be 172.16.0.0/12 greater than or equal to /24. I have a bunch of, so there are going to be routes that are going to come through that are going to be /32. So, but I want to allow, and I believe that's only over here. Yeah, so I'm going to go ahead and there's going to be /32 routes. So I'm going to go ahead and make a small modification. So it's going to be, I'm going to say actually less than or equal to 32. just like that. And then I'm going to do the last one here. I'm probably not going to need 192.168, but I'm going to say it anyway. I'm going to go ahead here and say 192.168.0.0/16 greater than or equal to /24. So if I do show IP prefix dash list, and I say detail, nothing's going to get applied yet because there's no matches. So I'm looking for /24 routes. Do show IP route. I should have a bunch of /24 routes in my routing table, and I'll have a handful of 172.16. So I'm getting the okay, so redistribution, I'm getting /24s, which is fine. So that's coming through the way that I would expect it to, which is good. So now I'm going to go, actually, I'm going to make a do show run section prefix dash list. I'm going to go ahead and make an adjustment to this entry right here. And I'm going to say greater than or equal to 24. Just so that it lines up. So now what I'm going to go do is I'm going to type in router BGP 65001. I'm going to type in underneath the neighbor statement, so neighbor 192.168.31.42. Actually, I'm sorry, address family IPv4 unicast. Neighbor 192.168.31.42. And I'm going to put in a prefix list. And I'm going to say prefix list, and the name of the prefix list is going to be, what do I call that? Prefix list MPLS VPN advertised. And then I'm going to say outbound. Filter outgoing updates. Out. So what's going to end up happening now, or what should end up happening, show IP prefix list detail. I should have routes that are getting matched. Hopefully it should work. Should match on the routes, and if I do a show BGP IPv4 unicast neighbor 192.168.31.42 and I say advertise routes, I'm not advertising any routes to him anymore. So that seems to be, the hit count is 0. Let me see if I'm learning anything on 42 anymore. So if I do a show IP route VRF enterprise, I am learning all these subnets from 45 now, which is what you'd want to see. So now what I get to go do is do the exact same thing on 35. So whatever I did here, so show run pipe section prefix dash list. I'm going to take these entries right here. Now there's a deny any of the other routes out. So I'm going to go over here to 35, global config. I'm going to paste these in, and then underneath do show run pipe section BGP. I'm going to type in router BGP 65035, and then underneath address family IPv4 neighbor 192.168.35.45 prefix list. And then this prefix list name, out. Now that I've done that, if I go to 45, and I hit the up arrow, those routes should all go away. It'll take some time for BGP to propagate the update, but 42, those routes should all go away. Let's see if it's going to trigger on this side. If I show IP prefix list detail, there we go. That's so if I show BGP IPv4 unicast neighbor 192.168.35.45 advertise routes, I'm not advertising anything to him. I look at 45, there's no routes in the routing table. So now that we've got that laid out, now what we can do is we can, since we're filtering outbound, what we can do is we can go ahead and advertise what we do want to have. So there's a couple different ways that we can handle that. We can either we can go and do redistribution on 31 from OSPF into BGP. So if I was on 31, and if I go and get out of the way real quick. Do a show IP route OSPF. I have all these routes right here that I can essentially go in and do redistribute, go under BGP, redistribute OSPF into BGP, and then go underneath OSPF and redistribute BGP into OSPF. So we can get dynamic route propagation set up that way. So the other one that I want to do is I don't want to advertise this route either. So the way that I would do that is if I do a show run pipe section prefix dash list, I'm going to have to go to global config and I'm going to say this one here because I don't want to accidentally advertise my default. I'm going to say sequence 20. Actually, it won't. It won't do that. Never mind. I don't need to worry about that because it's not going to do it. So on 31, what I am going to go do is I'm going to go ahead and say router BGP 65001 underneath address family IPv4. I'm going to type in redistribute OSPF 1 and I'm going to type in as far as I know, I'm going to have to do match external routes, match external 2 routes, because I don't want to match on everything, just external. So do show run pipe section BGP, match external routes, perfect. Now if I go to 42, I'm only learning the internal routes that I want to see, right? And that's a good sign. I'm learning the routes that I want. That's a good thing. So that's being advertised. Now I need to do the exact same thing from, and this is going to be a little bit different on the CSR35 side. I'll show you what I mean by that. CSR35, if I look at CSR35 isn't going to be learning a bunch. But what I will be learning if I do a show IP route is all the routes from, if I do show IP route BGP, I'll be learning all the 10net routes, right? Which is what I want to see. Now, if I want to, because CSR35 doesn't have any, what I would consider dynamically routed subnets to it, so there's nothing sitting behind 35, right? So what I would do is I'd go underneath BGP and just advertise the 4 loopback address subnets into BGP so that 31 can learn them and go from there. So let me go ahead and do that real quick. Show run pipe section BGP. I'm going to go underneath router BGP 65035, address family IPv4, type in network of 10.35.0.0 mask /24. And I'll do that for .1, .2, and .3, respectively. Now, if I go over to 31 and I do a show IP route, I should see 1035 starting to come across. It'll take a minute or so for everything to come across, and that's okay. But that's exactly what I'm looking to do. Now, that's OSPF to BGP redistribution on 31. I still have to take BGP routes and redistribute them into OSPF. However, only the RFC 1918 address space. That's the caveat here. I've done the easy way. Simply just grab everything in OSPF that's an external type 2 route and bring it into BGP. Now I need to go into BGP, bring that into OSPF, but I don't want to have all these other prefixes. Now, what I can do is I can call that route map, or the prefix list from a route map and allow only RFC 1918 space. So let's go ahead and knock that out real quick. So I'm going to go to global config, route map, and I'm going to type in RM, BGP to OSPF. And I'm going to say match IP address and prefix list, and the prefix list never shows up. I'm just going to call it MPLS VPN advertised. Even though technically speaking, it's not the right one. I could rename it and use a different prefix list. But I'm going to go type in router OSPF 1. I'm going to type in redistribute BGP 65001 subnets matching the route map of MPLS to be a BGP to OSPF. So now, if I go to switch 27, for example, and I do a show IP route, I'm not going to be learning any of those other routes, but I will learn the 1035 subnets. Okay, so let's take this a step further. If I go further into the network, and I look at, say, switch 2022, I do a show IP route, I should see 1035 subnets in here, but I don't see anything else, which is what I want to see. So this is route control. Now, if I go over to my other secure CRT session, and I look at, say, PC 67, let's do 66, and 66 is right here. Let me go ahead and try pinging 10.35.0.1, and I can ping it. That's a good sign. Now, could I trace route to it? Let's do a trace route to 10.35.0.1 numerically. And I can reach it all day long. So I hit my gateway, I forward to Nexus 9K7, I hit CSR 15, switch 27, I hit CSR 31, then I hit CSR 42, then I'm in the backbone. This is all MPLS forwarded traffic because we can see the labels. And then I hit CSR 45, and then I hit CSR 35. And I'm able to hit my traffic all day long. So we have end-to-end connectivity through the MPLS backbone. And that's basically what you would expect to do. Now I'm going to continue doing this process here for 45. We get 36 squared away. And let's go, and so I know that's working. That puts takes a lot of pressure off of the configuration, so we don't have to do any weird, any of the more complicated stuff we don't really have to worry about. But everything we did at 31 will have to happen on 34 and 36. So I don't want to advertise all these subnets to there. So what I'll do is I will grab some of the config from these devices. So on 31, I'll go ahead and do a shill run section prefix dash list. I'm going to go ahead and pull up Notepad. I'm going to grab this config right here. And then I'm going to say shill run pipe section route dash map. Get that knocked out. And then we'll do shill run pipe section router. And then I will do OSPF. I'll grab that one. But I'll take the router ID out. And then BGP. And then address family. Just like that. Okay, so now that I've got all that squared away, I can do this on CSR 34 and then set up the BGP peering outbound. And I also need to do, this will be underneath the address family. It'll be, let me just go ahead and steal this and I can just update the IP addressing. This will be 3447. Just like that. So let me just make sure that config looks correct. So I have my prefix list allowing RFC 1918 space, matching that on a route map, matching that for redistribution from BGP into OSPF, and OSPF1. Yep, all looks good. So let me go ahead and on this guy here, type in neighbor 192.168.34.47 remote AS of 4, and then I'm going to go 192.168.34.47 activate, because if you don't have that in there, it won't work. Go to 34. Go ahead and paste that config in. Now let me go to 47 and get that peering configured. We're going to type in route dash policy pass, exit out, router, and we need to create the VRF on this side. The VRF configuration on 47 is a little bit different, but it's for the most part it's the same thing. So I'm going to go ahead and type in VRF. VRF name is going to be enterprise. Underneath here we're going to type in the address family first. Address family IPv4 unicast, and then we need to do an export rule, export route target, and then underneath here we're going to say the value is going to be 10.0.0.047:4, exit out of that, and then we're going to do a import route target, and it's going to be 10.0.0.42:4, 45:4, and 48:4. Exit out of that. Show config. So not terribly involved, but it definitely needs to be there. Then we're going to do router BGP 4, and then underneath VRF enterprise address family IPv4 unicast. I'm going to exit out of here, and I'm going to type in RD. In this case here is going to be 1:4, and I believe that's what I used on CSR 42. Show run section VRF 1:4. It is. So 1:4, and then I'm going to, underneath the address family, I'm going to type in neighbor 192.168.34.34, remote AS of 65001, address family IPv4 unicast, and then route dash policy, and then we're going to type in pass in and out. Show config. That's all the syntax we need to do. So I'm going to basically just grab all this config right here, copy it into Notepad, just like that. And I'm going to commit it, and let's make sure I didn't make any errors. I didn't. So on 34, we should get a peering here momentarily to AS, the service provider. Assuming I've done all my work correctly. Do show IP interface brief. 3434, do ping 192.168.34.47. Okay. Do show run pipe section BGP. Okay, that's looking pretty good. All right. Now, if I look at 47, do show IP interface brief. Gig 0. Oh, yeah, okay. So I kind of overlooked one step. I'm like, why is this not coming online? Do show run interface gig 00001. It's not in the VRF. So, interface gig 001. I'm going to go type in no IPv4 address, and we're typing VRF is going to be enterprise. IPv4 address is going to be this address, and commit. Now, momentarily, I should have a BGP peering up once it can talk, just like that. So now if I do show BGP VRF enterprise IPv4 unicast summary, I can see routes coming in, and I'm learning a bunch of routes, which is how you would expect to see it. Everything's looking pretty good at this point. Okay, so now here's an interesting conundrum. I'm going to hold off on doing 48 because 48's not set up yet. I'm going to do the connection to 45 and 36 here in just a minute. Here's the interesting part. What did we do on 31? We redistributed OSPF into BGP. So what would that do to say, and I'm just thinking about this and what all I've done so far. What would that do to say CSR 16? Should I be learning routes? Show IP route? Should I be learning all these routes in the routing table? The answer to that question is no, I should not be. So what I actually need to do, and this would be for the internet side of the house, for all of the links downstream to the customers, I would have a prefix list that would basically have a bunch of entries in it of routes to not allow. And anything RFC 1918 would not be allowed in. So let me give you an example of what I mean. So I'm going to go ahead and let me get out of the way real quick. Go to the global config and type in IP prefix list. We're going to call it PL routes not allowed. And I'm going to say deny 10.0.0.0/8, and I would say less than or equal to 32. So I want to I don't care what it is, I want to match on it. I'm going to do 172.16.0.0/12, and then I'm going to do, this syntax should work just like that, and then I'm going to do a permit 0.0.0.0/0 LE32. This should allow everything else if I'm doing my configuration correctly. So that would get applied inbound on any of the BGP peerings. So do show run section BGP, and I have this peering right here. I'm sorry, no. That would get applied. So I'm sorry, this would be, okay, so my mistake. Not a prefix list, but an ACL. An ACL to drop this traffic because it get applied to the interface level. So if you're doing BGP, you could apply it to a BGP peering. Now that I've got it built, I'll probably use it where there's BGP, but in this case here, I don't have a BGP peering to here, so I'm just going to use an ACL. So in the ACL would be IP access list extended, and we're going to call it ACL routes not allowed. And then I'm going to go underneath here and type in deny IP, and I'm going to type in, I'm going to say as a source 10.0.0.0 0.0.0. Oh, sorry, 255.255.255 to any destination, and then deny IP to 172.16.0.0 0.15.255.255 to any destination. And we're going to do deny IP 192.168.0.0 0.0.255.255 to any destination. And then I'm going to do a permit IP any after that. And then I'm going to go to interface gig 3 and type in what do you call it? So this actually won't work on this connection because I'm not learning the routes from them. I'm learning the routes from 28, but I could apply the prefix list filter on there. But let me go ahead and do IP access group, and then it's going to be ACL routes not allowed in inbound packets. So if I do a show IP access list, this traffic right here will be blocked, but everything else will be permitted. So now if I go to 17, because I believe 31's got a peering to 17. If I go to 17 and I log in here, I do a show BGP IPv4 unicast, I am learning routes. Traffic is being learned in, but I'm also learning, preferring 11731. So the traffic is coming in that way. So what I'll do is I'll create a prefix list here and apply it to the route map or to the BGP peering. So do show run router BGP. I do have an active peering here, so I will create a route policy that blocks, that's inbound right here. So I'll change the name of the peering. So it'll be IP prefix list, prefix dash list. Sorry, why is prefix set IP. What are my options here? Prefix dash list. I guess I have to do a set. Prefix set, and we're gonna, what do we got to name this? We're gonna say prefixes not allowed, and we're gonna say 10.0.0.0/8, and we're gonna say GE LE less than or equal to 32. Then we're gonna do 172.16.0.0/16 LE32, and then we're gonna do 192.168.0.0/16 LE32. So if I jump out of here and do a show run pipe section prefix dash set, show run prefix set, prefix is not allowed. Commit. So I'm going to basically be blocking anything 10 splat. So now I need to call that route map. Route policy is going to be, this will be PL routes not allowed. And then underneath here, I'm going to say if the let's see, where is that I'm looking for? Source prefix. That's what do I want to use? It wouldn't be if route type is, yeah, see, I don't want to do that because that's going to be specifically in route types. If prefix, if the source and member of a set, prefix is not allowed, then we're going to drop, else we're going to pass, else, and then end if. So show config. The idea is if the source is in prefix is not allowed, then drop, else pass, end if. So let me commit that and then go to show run, do show run router BGP. So theoretically speaking, if I go to here, I type in route policy, prefix is not allowed, I say inbound, show, and then commit. Now, if I go down to here and I do a show BGP IPv4 unicast, I should not see any of those routes, hopefully, coming in. That's the idea, is to block all this stuff outbound. But here's the thing. I could theoretically do the same thing on CSR31 outbound as well. So the XR syntax I might be a little off on, but it might take some time for that to trigger. Because if I look at 10.3.13, or yeah, it's being learned from 31. I don't want it to be advertised. I'm trying to block it, essentially, from being learned in that way. I don't know if it's actually going to work. I hope it does, but it's still preferring. Yeah, so I might have to go in and just do the same thing I did and just block RFC 1918 from being advertised. So on the internet. So again, one of the things I was talking about just a minute ago, where in the event that you're putting your routes into a routing table, and whether you're doing just a static default outbound, and I could actually probably just configure this probably just as easily. If your internal routing is staying in the default VRF or the global routing table, and you're also peering to the internet, whether it's just a static default route, if your outside interface is inside of a VRF, or you're forming a BGP peering inside the VRF, then you can learn those routes in on the edge, which I haven't met a customer yet that needs anything more than a default route. So from a provider to customer perspective, just a quad 0. But from the customer to the provider, there shouldn't be any of those routes being advertised. So in the event that you're doing that BGP peering, if you got two different routing tables, the one on the and I'm going to do this one here because it's on the right for you. This one facing the internet is in the VRF. This one is facing the inside. When traffic gets to where it's got to go, there'd be a static default route or a default route via BGP to where we got to go. And you can route leak that back and forth. It's easier to do a static route because then you can do an IP route, VRF, whatever, and point it. It's a little bit more difficult when you're doing it via BGP because then you've got to be able to say, I forget the actual syntax. You've got to like allow the VRF to leak the default, and it's VRF route leaking. You've got to allow like trying to think here, prefix list to match on the default. It's called from a route map, and then you do a route leak, an export from the VRF outbound to the global. I'd have to look at the actual syntax, but that's one way to do it. So just to keep things simple, though, on CSR 31, I'm just going to go ahead and advertise. I'm going to go back to 31. Go ahead and bring this up here. On 31, I'm going to go ahead and take that same route. Go ahead and get out of the way. Show run section BGP. The same prefix list that's attached to MPLS, I'm going to do create a different one. Or sorry, I'm going to have to create a different one that allows just show IP prefix list. Right, so I'm going to say I need to create one that says deny. So what I'll do is I'll go up here, I'll type an IP prefix list, PL, internet not advertised. And then I'll type in deny 10.0.0.0/8 greater than or equal to 23. And then I'll do 172.16.0.0/16. And then I'll do a, sorry, not 16. We'll go, this was supposed to be a 12. Sorry. And then we'll do, and then we're going to go, so this will be 16. This will be an 8. And this will be a 9. So do show IP prefix dash list. So we have not advertised. No. Let me hit the up arrow a couple times. Go back to that 10. There we go. So 10, 15, 20 is denying that, and then I need to go in here at the end and do a permit 0.0.0.0/0 LE32. That should allow, actually no, because that's being advertised outbound. So I'm not doing any network statements on this side. So that should be fine. So I don't actually need this. So if I do show run pipe section router BGP, and then I go to here, I type in prefix list, and I call internet not advertised, and I say outbound, and then I come over here to CSR, this is XR17. Those routes should eventually stop being advertised or learned by that. So let me go back to 31 and do a show BGP IPv4 unicast neighbor of 1.17.31.17 advertised routes. Yeah, I'm not advertising any routes, so 17 should no longer be learning them via 1.17.31.31. And that's the expected output. That's what I wanted to have happen. So that's how that would work. Now, I know my XR syntax is off, and I'll be honest with you, I haven't touched XR in quite some time. So syntactically, I know I'm wrong, but that's okay. I'm not terribly concerned about how that would come into play. So that's one thing from a routing configuration perspective. I would have to spend some more time in those areas to get that squared away. So now any other locations, the 34 would need the same thing outbound. Now, the reality of it is, more often than not, you're not going to be receiving any routes in, therefore you won't be advertising any routes out. So, and you wouldn't be doing a full redistribution into BGP. You would, where this is an exception to the lab because I'm basically kind of being willy-nilly about it. The customer would learn a quad 0 default, but we wouldn't be advertising everything from OSPF into BGP. We wouldn't allow that outbound. So if you didn't have everything in the routing table, I'm sorry, if all of your interfaces in the global routing table and you did have this situation, the provider is going to tell you, hey, we're receiving these additional routes from you. They're going to have their own filters in place to not allow that to go anything beyond their edge and into their backbone or advertise out to any of their other connections. So 17 might see it, and when you're setting up this BGP peering, setting it up, then they would say, hey, I'm receiving all these RFC 1918 routes from you. You need to either we'll block it on our side, or we'll need you to do a filter. And what you would do is you would essentially do what I'm doing here. You would go to 31, and then you would make sure not to advertise any of these routes out. So if I go back to here and do a show run section BGP, I've got prefix list internet advertised. So I'm MPLS VPN advertised. So I want to make sure that I'm advertising RFC 1918 over MPLS, but not out internet. So I don't learn any routes that I shouldn't be. But if I do a show IP route, I should still see a bunch of routes on my routing table. And if I wanted to, I should be able to ping 3.20.32.32. I should still be able to ping that. And that's going to be a DMVPN hub. So that's basically where that would come into play. So any of these other remote sites that are learning this stuff in, then I would have to make sure that anywhere that we're doing local, and this would be the only time we would do this because this is where we're going to do redistribution is on these boxes. So 34, if we were to look at 34 appears to 39. So let me go ahead and get out of the way and let's look at 39 as well. What does 39 see? Show BGP IPv4 unicast. So I'm learning 34, 39 from 34. I'm doing the same thing. So I'm on 31. I'm going to do a show run pipe section prefix dash list. And I'm going to take these routes right here over to 34. Copy and paste those in. And then go do show run pipe section BGP. And then I'm going to take this peering right here and type in prefix list prefix list not internet not advertised outbound. And do show BGP IPv4 unicast neighbor of 2.34.39.39 advertised routes. And I go back over to 39. Momentarily, he's not advertising the routes anymore, but it's going to take a minute for him to update. So clear BGP IPv4 unicast star soft. There they go. So now I'm learning 231.74.31. So now oh, I didn't realize I had a second peering. That's my mistake. 31's got 2 peerings. Show run pipe section BGP. That's my fault. So let me go ahead and do the same thing again here to this guy. Prefix list. Just like that. And we're going to pull this one out and throw this IP address in. Not there. And then on back to 39, we shouldn't be learning any 10 splat. Now we're learning it from 235.45.35. Where's that? Oh, we're learning that from over here. Because CSR 35, I wonder if that's why. Oh, so I've got all this route traffic coming over here. So what's happening now is 35 is advertising outbound. So do you see how this can perpetuate itself? If you're not careful when you're planning how you're going to do your config. If you're just being kind of willy-nilly about it, this can cause you lots of problems. And before you know it, you've got the phones ringing, you're trying to figure out why traffic isn't going, you're advertising traffic where you shouldn't be advertising it. So let's go ahead and knock out 35's configuration and 36. So we'll have, let me just make sure that they're peered, the way that they're peered. So on 31, show run pipe section prefix dash list. Let me take this guy right here over to 35. 35 should have a single peering. Show BGP IPv4 unicast summary. And I have a peering out to that one. So let me go to global config, paste this in here, and let me go to 36. Because 36 also has it. Show IP route. 36 is learning those in as well. So let me go to global config. Because based off of the do show BGP IPv4 unicast summary, yeah, I need to do that command out as well. So did I already paste that in? I had not. Let me go ahead and paste that in. And let me go ahead and make sure to attach those configurations to the appropriate next hops. So do show run pipe section BGP. And what I'm going to do is I'm going to take this right here, and then this guy right here, and say prefix list internet not advertised out, and then do the same thing on 36 for that peering. So do show run pipe section BGP, and on this guy right here, I'm going to take this guy right there and type in prefix list not advertised out, just to make sure that any routes that I do learn, I'm not advertising 10net outbound or anything RFC 19. So now if I go back over here to where was I before? I was on 39, I think. So let me go ahead and do this. So, and that's better. Now any of the 10 nets that I was learning are now all gone. So that's good. So all that's been taken care of, and any connectivity that I do have is now squared away. So let me just make sure that everything is good. So from 45's perspective, if I do a show run section BGP, I've got one peering to 35. I need to do another peering to 36. So let's do show run interface gig 3, interface gig 3, VRF forwarding enterprise, and then let me reapply the addressing. Just like that. And then do show run section BGP. We're going to type in router BGP4, address family IPv4 VRF enterprise, neighbor 192.168.36.45, or I'm sorry, 36.36, remote AS of 65036. And then the activate command is already there. So now I get to go to global config, router BGP 65036, and then neighbor of 192.168.36.45, remote AS of 4. Okay, so do show IP route. So I'm getting routes the way that I expect them to, right? And that's what I want to see. So then I get to come in here and advertise my local network. So it's going to be network of 10.36.0.0 mask/24, 36.1, 36.2, and 36.3. Okay, so show BGP IPv4 unicast. I'm going to have routes on my routing table that are going to get advertised, but if I go to CSR31 and I do a show IP route, I should see 1036 will come across. I've learned just a couple of them so far. They'll come over in waves, but then I've also got all these other routes coming in via 47. Sorry, no, 74. So next is 74, but that's okay because it's a lab. I'm not too worried about it. We'll talk about more about default routing at a later point. But the base point that I wanted to make was getting route propagation where you need it to be, and then filtering the routes out that you don't want to either send or receive. In this case here, we didn't want to send RFC 1918 traffic out to the internet, and we didn't want to send any internet learned routes from here over MPLS because that could cause a routing loop, right? We don't want to do that. So now if I take a path somewhere in the network via an endpoint, let's say PC66, since we're already on PC66, and I want to ping 10.36.0.1, and if I want to trace to it, 10.36.0.1 numerically, I take my happy self all the way over there. But now if I wanted to ping 3.20.32.32, I can ping that because that's CSR32, and if I do a trace route to 3.20.32.32 numerically, I flow through the firewall instead. So I can get everywhere I want to go via the path I should be taking. Firewall, MPLS VPN, etc. Now it's going to get more interesting when we go to set up DMVPN, because what we're going to end up happening here is basically overlay tunnels. Let me bust out my pen tool real quick just so that it's going to make more sense. There it is. So I'm going to go ahead and pull up my pencil. Actually, let me pull up my... So right now, the path that we're taking to get anywhere we want to go from PC66 is basically coming from... Let me bring this down just a touch. I'm coming from here. I'm going this way right here. Actually, PC66. I'm going this way right here. If I want to get to CSR36 and ping 1036, if I want to get to here, right, let me go ahead and, if this is my destination, I'm taking this path right here. Like that. That's my flow. Now, if I want to get to 30, 33, 33, 33, from here I take this path instead. Actually, let me change my color. If I want to get to here, then I take this flow instead. Something like that. I might have it might be this way. Actually, no, take that back. It would be this way. Like that. Or it might deviate slightly, go this way. But either way, actually, I bet you any money it goes this way. I haven't actually mapped it out. Something like this. Or it might come down this way and go out. But either way, I get to where I've got to go. But that's how the path comes into play. Now, if I add DMVPN over this, let me go ahead and draw a line. Let me go ahead and clear the screen. I'm going to be basically building tunnels to these guys. Right? Now what that's going to end up doing is anything that I want to reach at these locations will then ride this way. I'll come in here to this guy, hit, and I'll ride the tunnel to him, and to him, and to him. Now what'll be interesting is I'm going to be I'm planning on building DMVPN tunnels over the internet and over the service provider, MPLS. So we have two different, so we'll have two DMVPN clouds, and we'll have single hub and dual hub. That is the game plan. So we'll see some interesting forwarding designs when you go and you bring in overlay tunneling and how that'll come into play. But that's going to be a discussion for another time and how that'll work out. And then to wrap things up, I will come in here and we'll get these colos online one at a time, obviously, so we can peer back over here to this colo, or to our HQ data center, for replication purposes. So I might only do one peering, but I do want to basically get both of them working and see what that would look like. Because right now, utilization-wise, I'm looking pretty good. I want to see how much further I can push it, though. I'm, you know, all that stuff that goes along with that. So if you guys have any questions, please leave a comment down below. If not, please like, share, and subscribe. That definitely helps the channel out. I hope this is making sense to everybody. And I will see all of you in the next video.